Hey guys, how's it going? In this video, I'm going to go through Leetcode number 140, word break number 2. This question was asked by Facebook, Amazon, Google, Bloomberg, and also Microsoft, Uber, and Adobe. This problem, we are given a string of S and a dictionary of strings word dic, and as basis in S to construct a sentence where each word is a valid uh, dictionary word, return all such possible sentences in any given. Let's take a look at the example in here. The string that we are giving is cat and dog. Cat. So the output should be cat and dog. That's one possible output. Another one is a cat, sand, dog. As you can see, so we basically slice the given string, such that each individual word can be found in the word dic. So we slice this way: cat, which is this word over here, that's in the dictionary, and also in the dictionary. The dog is also in the dictionary. Same thing for this guy. We slice it in cat, sand, and the dog. So basically, the way that I approached this problem was the use of recursion. As you can see, we can basically scan through this string. For example, we scan through the first, for example, the first three character, and then we've found that it can be found over here. It's matching over here. And then we scan through the first four character, which can be found in here as well. And then let's say after scanning the first character, and then this one will be the remaining part of the string that can be performed recursively. Basically, we scan the first four character of the remaining. After that, we scan the first three character of the remaining. And same thing when we do cats, and we can scan through this substring, and then basically we can look at the first three character. After that, we cut it off, and then we look at the first three character. In this case, we cannot scan the first four characters. We have only three characters in this case. So that's the idea. Let's look at the implementation. We first have the length word map, and thus we use a default dic, that's a set. So basically, the key are the length, and the value are the word in the dictionary. And then we look at the minimum length. So basically, that's the length of the shortest word in the dictionary. And then what we do is to fill up this that's length words map. Let me show you what it is. So again, the key is the length, and the value is a set that's containing all the word in the dictionary that is correspond to that length. For example, length of 3. So we have and, dog, and cat. All of them has a length of 3. So after that, we are good to implement a recursor, which we will recursively call this function. If the given string, I call it a string, is already equal to empty string, and then that means we are done. So same as all the other recursive function. The first thing we have to do is to figure out the termination condition. And if we hit that, we just append it to the result by decomposing the list, convert it to a string, append it to the result. And also, if the length of the given string is less than the minimum length, that's why we have to look at the minimum length, the length of the shortest word. If the given length is already smaller than the length of the given the length of the shortest word, we are done as well. So we don't have to do the rest. And for the length in the length words map, so basically in this case, the word length could be 3 and could be 4. And we look at the substring of the given string. If that is matching one of the words in the set, that means, so basically the scanning, right? So for example, the first word length will be 3, and then we look at the first 3 character of the substring, which is cat, to look it up to see if that's in the set. In this case, yes. So we copy a copy of the given list. We call it B list, and then append the word that we found it in the set. We append it to it, and then we put the B list to be input argument for the next recursion. And then after that, we do the next length, which is 4 in this case. So we basically scan through the first 3 and then the first 4. And then we recursively calling remaining. To trigger running, we input the first string, also the empty list to start with, and the result I put it as a set, so we can avoid a duplicate. And then at the end, I convert it back to a list. Let's submit it. I've admit this is not the most efficient solution. As you can see, it's not very efficient as compared to other submissions. And one potential improvement would be that we can implement a dynamic programming instead of like a pure recursor. As you can see, a lot of repeating work being done in here. I leave it as your exercise to you. Basically, we can implement a memorization, either a list or a dictionary to keep track of the intermediate step that we have done, so we don't repeat our work. So that would be a lot more efficient. So this is my solution. Hopefully this gives you a starting point to optimize the solution for this problem. If this is helpful, please like and subscribe. That will be a huge support. And I will see you in the next video. Thank you so much for watching.